Alright, welcome back to, I guess, another tutorial for Exiled or developing plugins in general. This video is going to be covering patching, which you should have seen in the title. And to begin with, I mean, all patches really have to have a purpose, so what I'm going to start with is providing context behind what I'm going to patch and why. So currently there exists a bug in on Exiled, which was fixed, albeit poorly, um, but there's a whole problem with the goggles, SCP-1344. Here, this is just the decompiler in JetBrains writer, so I'm just going to pull up the actual item itself so I can show you the code. Alright, so here is the 1344 item class, and what I am looking for is this event here. So there was a change recently. Northwood added this. Well, I don't know if they added this event, but they changed goggles to use this event. And what happens here is every time your entire inventory gets dropped, like from getting killed, or having someone like handcuff you, or like getting a Marshmallow Man effect during like Christmas, or like losing all your items as skeleton. If any of those things happen over here, this code will fire, which will basically just check if the owner of this item is the person who lost their item. If so, well, if not, it returns. If so, then they drop the item. If the person was wearing the goggles or something, they'd activate the effects. These things here just saying for idle, equipping, and inspecting, like putting on the goggles or just looking at them. Just don't do anything otherwise. If it's something like all the other different statuses, like probably equipped or unequipping, then it would just activate the effects like losing your eyes. But the key thing here is that it just drops the item, and how this code works is it just literally spawns a pickup and then removes the item from the inventory. There's actually no check here of whether or not this item exists in the owner's inventory to begin with. Even if you check here, the server create pickup, it doesn't actually use the inventory for much. It actually just uses it for positioning, like where to create stuff. It doesn't actually check anything there. So because of this, if you actually have two things call this event here on the same tick, then you would call this code here on this twice on the same tick, and it would run this code because, I mean, it's the person, it would eventually run for the person who, it would run for the correct player, it would pass this check, it would call this code twice. Because it doesn't actually check the owner's inventory for the item, it would actually just create a duplicate of the item. And it's not really a true duplicate. Both items have the same serial, so if the same player picks up both, the second one vanishes, but still, this is a pretty major bug. And how this actually happens, what can trigger this kind of thing is, well, anything that calls this event twice, which comes from this method here, specifically. This thing basically always gets called as long as this method gets called. And you can see in here, actually, that this here actually checks to see that the item is still in the user's inventory. But if you check what actually calls this, it's things like having your status changed as 3114, which is like if you go from, I guess, disguised to undisguised, it just drops everything. If you die, you drop all your items. If somebody disarms you, you drop everything. If you get the marshmallow effect, you drop everything. And then if you get spawned with 1507, I guess you drop everything. stuff like that. And then, of course, you can just call this method here manually. So realistically, in vanilla servers, the worst thing that can happen is like maybe you die in the same tick that you get disarmed, and then you create a duplicate that way. But that's like a 1 in 60 chance, like, and assuming it's lined up reasonably well. But the real problem here is in exiled.events and then internal, and this is just a clone of the Exiled repository, and then I'll create a PR after I change what I want. This here, this event here, what it's intended to do is whenever your role gets set to spectator by basically any reason that isn't leaving the server, then you just drop all your items. So it's something like if a plugin sets your role to spectator. That's what it's intended for. And what's happening for, well, in the previous Exiled version before this here was concatenated onto this, what would happen is when you get killed, it calls this method here, which you see this call here from this. This would get called from kill player, and then kill player would also set the player's role to spectator for a reason that isn't destroying, and then most people have this on because, or have this config here on, and it would call this again. It would call server drop everything, and then in the goggle specifically, because there's no check here to see if the item was already dropped, it would drop the item again and create a duplicate. So what we're going to do today is change this back to what it was before the fix, and we are going to go to patches and fixes. We're going to create a new class. Just create a new class, create a boilerplate. Whenever you're working with this stuff, you can always just copy paste from similar locations. What we're going to patch today with Harmony is SCP-1344 item, which I have to reference, dot, and then this method up here, on player inventory dropped. And by the way, these error symbols, this is because Exiled has strict formatting. If you notice, everything has strict formatting. And sometimes there's warnings because some people don't like to follow those. Where was that? Yeah, here. Average Yamato moment. Yeah. So, for most things, I can just click fix button here basically, and it just puts things where it's supposed to be. Anyways, there's actually no bug report for this yet. So now that you have your class, the first thing you're going to start with is adding this Harmony patch attribute. And then we covered attributes already. You have some class or thing. You go to the line before it. You add these brackets, and then you just type out the attribute's name. And then in here, how to do a Harmony patch. There's many constructors for this. What I suggest you start out with, though, is first using this type of thing, and then SCP-44 item. Now, what this type of thing here represents, basically, is there is an actual class called a type. So here, if I just create a dummy method, there's an actual class for types defined by the system. And a type is something like this. So I can have an object that represents a class that I've written. This type of thing here basically lets you get the type of something in code that you've referenced. So like type, my type equal to type of, and I could even have it just be this. And then there's things you can do with types, like you can see the assembly they came from, their full name. You can also call methods on them, like if you know a type is an enum, you could get all the enum values, you could get all events in a class, all the fields. This is specifically from a library called Reflection, these methods, I believe, or it's just all these types of meta C# operations are considered reflection. If you go to system.reflection, which should be a namespace, yeah, there's stuff here for like assemblies, methods, whatever. It basically just represents code that people write as objects. So when we start out this Harmony patch up here with this, we're saying we're going to patch something in this type. We're going to, in this class here, we're going to modify something in here. That's all we've indicated to the Harmony library, by the way. If you next step is we need to define either a name or a method type. Well, actually, well, we just have to define a name anyways. So for this, you can use the name of thing. Now, what this does is basically just puts this as a string. Like, this name of thing here is literally it just compiles to this. But the key thing here is if this gets changed, if Northwood changes this, your compiler is going to throw an error when it can't find this. So it's good to use name of when possible, because then you'll know when something changes. So now we've told Harmony that we're going to patch this specific method. If you wanted to patch a property, like in here, these are properties. As you can see, they're basically just values that you can get or set depending on if it's defined. All of these seem to be get only, but it's basically a way to have something like a field where you can get this value or you could set it, but then say you want to wrap it around a method that checks other values and stuff, well, then you use a property. So these are get properties. When you call this, which is like calling a field, what it actually does is it calls a specified get method, which goes to here and calls this. So if you want to change these, then in here you would use the name of the property, which I could like put in here. So I could patch this here. But what I need to define is that in the method type here, I need to tell Harmony if I'm patching it, get or whatnot. But for methods, you can just leave it like this. So now we've told Harmony what we're going to patch. What we can now do is either use a prefix, postfix, a finalizer, or a transpiler. Each of them have their own things. Because I like to have my tutorials be very in-depth, I guess I'll just go over each. So to begin with, a void prefix, which is what this is called, by the way, is a prefix that returns void. Now keep in mind, when you make these prefixes, postfixes, transpilers, or finalizers, you can either define by the way, you can make this private. You can define the method itself as the name of what you're doing, or you can add an attribute, like a Harmony prefix. So this currently isn't necessary, but if I change this to my prefix, now this is necessary to tell Harmony that this is a prefix. So what a void prefix does, by the way, is when a method is called, it runs your code before the main method runs. And if you need anything like properties or stuff inside the method, You define it like this. And then if you need an argument that's called, do it like this. What's important is that you keep these parameters, they have the same name as in the method. And then this instance thing here does need to have both underscores. And for Exiled, we specifically have to add this pragma thing here to make the name work. Otherwise it would throw an error because of formatting. So for this, now we can check stuff like in the SCP-1344 item. We can check if it's equipped, etc. This comes from items, and we can do whatever we want. We can call their methods from here, but we can't modify things except these here. We can't actually modify like what happens after the prefix. If we want to change something like that, we would make this a bool prefix, which typically isn't that good, because if I return true, then I believe this... I'm actually going to have to pull up these docs. I always confuse myself, but if I recall correctly, returning true on a bool prefix skips the method, and then returning false doesn't. Let me just... By the way, if you want to read this stuff yourself, just go to this website, harmony.paradike.net/articles. You can just read any patching things there. Yeah, so... Okay, so return false skips the method, return true runs the method. So here I could run some code and then return true, and then, you know, if I wanted to skip this method because I'm maybe calling something else, I would return false. But the problem here is once you return false, none of the other prefixes or transpilers on this method ever run, so you can end up messing up other people with your own patches. So typically, if you're going to use a bool prefix, either do so in some private plugin where, you know, you don't really care if you mess up someone else, or use a transpiler, which we'll discuss later. There's also a void postfix. There's no bool postfix. How this works is it runs after the target method runs. So after a player's inventory dropped, we can get both the instance as well as the target hub, and then we can do whatever we want, run methods, etc. A key thing to note, by the way, is that this instance argument only exists if this method is an instant method and not static. If we were to patch a static method, which isn't in here, but I mean, well, here's a static method. If we were to patch this, per se, there's no inventory extensions instance, so we don't actually get an instance argument or parameter here. Just a key thing to note. And then there's also a finalizer. I don't know if this has arguments. Yeah, it doesn't. A finalizer is actually called with exceptions. You do something like this. And what a finalizer is used for is if some method is throwing an error and you need to make sure your code runs, if an error is thrown or something, then you would put a finalizer around it. And finalizers are typically fine. You can also modify the exceptions and return a new one if you want to add your own custom exceptions. And lastly, we're going to write a transpiler, which is the actual patch we're going to use here because they give you more control. Here's what a transpiler will look like by the time we're done with this. So a transpiler is a static IEnumerable of code instructions, which come from Harmony. And then you name it transpiler, and then it can have, dang it, can have two arguments. firstly, the original instructions of the method, or instructions from another patch, because transpilers can apply on top of other transpilers. There's also this IL generator here, which can be used to declare like other local variables you could use in the transpiler. Because what we're going to do is we're going to go to this method, we're going to go to the IL instructions, and what we're basically going to do is actually modify these instructions here to do what we want. So maybe we will need to declare local. You can also just exclude this parameter if you'd like. So now that we have this, we're going to set up some boilerplate stuff. For any transpiler, you should try to do this, unless you're like have one transpiler in some niche project you don't care. What you need to do is convert this IEnumerable of instructions to an actual list, while you might just go, oh, just do this, you know? Ta-da! It's a list now. The issue with this, though, is there are many transpilers in Exiled, and each of them declaring a list would be kind of a waste of memory, considering like a few seconds later the lists would end up going nowhere, getting recycled by what's called the C# garbage collector. Just gets rid of stuff you've put in memory after it's no longer used. What we're instead going to use is something called a list pool, which Exiled has its own thing for, which is actually just a wrapper of Northwood's one, but we have our own in case Northwood breaks their own. So this get method here, you could call it with nothing and just get a list with some normal amount of capacity that could hold instructions. You could also get one for using an IEnumerable of code instructions, which we have, and then you can also just get a list of a certain size if you need one. So what this does is it goes to this pool of lists of specifically code instructions, and then it gets one, and then it populates it with all the instructions in this method. And the use case here is, say, during exile.events, all these methods start to get transpiled and patched and stuff. The list pool could just have like one list of code instructions in its pool, but it keeps getting reused for every transpiler, and then it saves on a bunch of RAM. Anyways, this is like the kind of micro optimizations people do. But I mean, you should be considerate of these kinds of things when you have so many methods running. Afterwards, we're going to eventually get an integer index, and then what we're going to do in the instructions, we're going to insert a range of code instructions, which will define it with an array. You can also try to do it like this. The problem here is that the formatting doesn't work here. So we have to do it like this for Exiled because it's a rather old project. And then we're going to use a for loop. You can also use a for each loop. What we're going to do is just yield return the instructions itself, and then go to the list pool of code instructions, and then actually return the list pool. So what this does, this is an IEnumerable of code instructions. I think I covered this briefly before, but how an IEnumerable works is it's a method that keeps getting called repeatedly, and every time you do a yield return, execution of this method stops until something else calls for another code instruction again. And because of this, we can return every code instruction that we modify in our list here, and then afterwards we can return the list that we got from the list pool here. We can let some other method use it when it gets transpiled. And so even after this last instruction gets returned here, this method still gets called, and then it just returns a list, and then it returns nothing. And then the method calling this goes, oh, IEnumerable stopped. There's no more instructions left. So here's the boilerplate. You can copy paste it if you want. List pool might not exist for other projects. It's an Exiled thing, but there might also be other APIs wherever you're coding that can have list pools. Now what we need to do is get an actual index for where we'll modify these instructions. This stuff here is just pretty standard for inserting instructions. If you need to modify specific instructions, you'll just need to be able to get the index of the instruction, and you can literally go to that code instruction. You can take a look at any labels, which are used for jumps, which are also called breaks in C#. And then you can take a look at opcodes and operands, which we will discuss soon. What we're going to do is go here. I think I already might have not done this, but if you do Control-Alt-D in JetBrains Writer, you can pull up this here, which is the intermediate language of whatever code you're looking at. So what I want to go here is I want to go after this. I see this return statement. I want to go after this return statement and put in another check before this gets called here, this server drop item. So I just need to get an index that points to after return. How I can get this is pretty simple. I go to here, get my list, and I can use this find index method where I can use a predicate. I'll just use X for simplicity's sake. Now to fully explain what's going on here. This is the list. This is a method. How it works is it goes from start to finish of the list, and it checks the instruction with this predicate. If it returns true, then it returns the index of that instruction. Otherwise, this will be -1. And what this actual predicate is here is we're given a code instruction. We're checking its opcode to see that it returns. And once again, you can go to the Harmony lib website on transpilers, what code instructions are and stuff. You can just read this if you need more info. But a short explanation is, in intermediate language, this is what C# compiles to. It doesn't actually compile to straight binary instructions for a CPU. It compiles to this semi-language, which then your computer compiles while the code is like not being run, but when the code is loaded, it compiles to whatever operating system or machine it's running on. So here's the intermediate language, IL. It has its own indexing and labeling system, which is kind of weird. I don't really get it, but I'll start explaining some stuff. So this here is an opcode, and what it does is it represents something that C# is going to do. In this case here, if I just hover over this, it tells me what it's going to do. It loads the argument at index 1 onto the evaluation stack. This evaluation stack, I want you to just abstract into just something you call the stack. I'm going to pull up a whiteboard in 1 second, because I'm probably going to need to draw some of this stuff. So here I've got a whiteboard now. How a stack works is, say in our computer we've got some box that represents memory. I really wish I was good at drawing, but I'm not. So what we're going to say is these are chunks of memory, and then say this starts at like some super small value, and then here's a much later value. Keep in mind actual memory indexes might be in like hex or binary or something. But what this is just trying to communicate is how we've got 10,000 memory addresses here. This is your actual RAM stick on your computer. This is where all the hundreds of dollars are going to this. And how it works is at each memory index, there is a byte of data you can modify. You can, and a byte is 8 bits. So this is what 8 bits look like. It's a fair amount of data. It can represent any number from 0 to 255 inclusive. could represent true or false with just 0 or 1, etc. If you combine multiple of these, like 4 of them, you can represent what is called an int by C#, which goes up to like 2.1 billion with 4 bytes. You can also represent floats with 4 bytes. Doubles are just 8 bytes, and 4 bytes is 32 bits. So at each one of these memory addresses from 0 to some huge number, there's a byte, which is 8 bits, which can represent any value from 255 or however it's encoded. You can combine multiple bytes and stuff. And how the stack works is like each of these boxes here comes from some process. So like this could be Google Chrome, this could be Discord, this could be my code editor, this could be OBS, this could be this GitHub desktop down here, this could be my SL server. And then in my SL server, I'm just going to make it big so I can show what happens. There's going to be the C# process, this .exe that is running, that uses C#, and how it runs C# is it has something called the stack. We're just going to say that this entire memory chunk here is the stack for ease of simplicity. And how it works is every time a method is run, what C# does is first it adds on something to it adds a trace, I guess that's called, to the stack. A stack frame to the stack, I guess. And what this does is it puts on the stack what method it's running and essentially from what line of code it's happening. So whenever you see an error log, it's actually just a combination of these traces just stacked on top of each other a bunch. So when you see an error that says my method threw a null reference exception at this IL index at exiled.events.onChangingRole if my method was an event for onChangingRole, and it says at onChangingRole, and then it specifies the IL index of what was called or an onChangingRole or what, and then it goes up to what called onChangingRole, which is like server kill player at this line, which server kill player patch block, because Exiled patches its own stuff into it. Harmony kind of makes its own method. So it says in this patched method at what IL index the error was thrown. So that's what these things actually are. It's just the stack containing trace of stuff, and then above each trace, the method has its own place where it can modify, where it has its own data and stuff it can modify at will. I don't really know where local variables are stored during methods, but C# runs off a stack, which is what we're showing here, and say, here, I'm just going to pull up this, I'm going to just, here, maybe I can, yep. So here I've pinned this window to the top so I can draw here while you see this. We're going to go step by step what happens here, just to give you a feel of how the stack works. What happens here first is it calls load arg1, which is this target hub thing, which was a parameter, and it loads onto the stack, I guess, a reference. Here, let me pull up some text so I can make things smaller. Why? Surely there's a way to make this smaller. I don't think there's a way to make this smaller. That's strange, but here, I'll just put this here. So there's a reference to target hub, it loads on that. And then next thing it loads is a reference to the SCP-1344 item, which is this, which is load arg0 in instance method. Keep in mind that for a static method, load arg0 is the first parameter. But here this first parameter is load arg1 because for instance methods, I mean, you could really just think of it as a static method, but it has to be called with an instance to something. So now here there is a reference to SCP-1344 item. It's just chilling here. Next thing it does is it calls this method up here. Actually, don't need this to be so big, just need to scroll. Get owner. It calls this get owner and is trying to do so on a item base. So what happens is C# has this stack thing here with the trace of previous methods, own stack, previous methods trace. Like, keep in mind, when you call another method in here, what it's going to do is it's just going to say, all right, ignore this. This is now trace. This is just previous stuff that was called. And then it goes into this method here, which we could decompile. It's a property, a get property for an item base. So then it goes into here, and then it calls this get owner thing, and then it uses SCP-1344 item as the first parameter. Properties are like instance methods, which are like static methods that require an instance. I hope you're understanding this. So now we're no longer in the stack of this on player inventory dropped method. We're going into the stack of the get owner call, and what it does is, I think it just, I mean, honestly, fine, I'll just decompile it. Yeah, it just goes to a field. If you ever see anything like this is just a field generated by the compiler. This is basically the same as public reference hub owner get : set : and then the compiler just secretly adds its own field and stuff. So I'll go back to this, make it small again. In the trace, it calls the get method, and then what the get method's gonna do, actually I should just pull up the IL of that. Okay, let me find this. It's going to take me a second. It should be in here somewhere. Yeah, you can see these get and set methods. All your properties are just secretly methods. Oh, I think I saw that. Yeah, here. So here's the get owner method that gets called when you call, like, reference hub owner equals item.owner. It secretly just calls get owner. And what this does is it loads the arg0. So now what's here is the trace of the previous method, our drop everything method. And in here we're calling get owner, which has a reference to the 1344 item. And what it does is it loads another reference to the 1344 item. If I can just, I want to copy this. Fine, jeez. It now loads a reference to the 1344 item. It then loads the field, which is stored somewhere in memory. Probably the heap, I don't know. And what it does is basically it just think of it converting this reference to 1344 item. It just converts this to a reference to a reference hub. Now, I know we're already on a bit of a tangent, but I'm going to go into even more of a tangent. This reference keyword is very key. All right, there's a big difference between classes, structs, and things like ints. A reference is only for classes. Maybe someone else, like events or something. But a reference points to something like a class. And how that works is when we call this getOwner method with the reference to the 1344 item, whenever we do anything like load field on that reference, we're talking about the same thing here. But if it was a struct is a value type. So Unity 3 has a vector3 struct. So say this was loading a vector3, this wouldn't be a reference to a vector3. This would just be a vector3 on the stack. All right, it's the actual data on the stack. It's a very key distinction because of many things you might struggle with when patching. My advice, if you're struggling with a patch, just ask on the Exiled Discord and transpiler questions or something. But yeah, keep in mind that references and value types are very different. Value types are structs, ints, floats, stuff like that, and references are classes. So now we load this reference to the reference hub, and then we call return here. And then what return does is if there's something on the stack, and this method's supposed to return something, it returns it. So what we do now is we go out of this trace, which is loaded onto here, because when we go into this getOwner method, we add on to the stack trace that's on the stack, and then we specify like what called this line, etc. And we now get rid of that because we're no longer in that method. And then we go back to the method we're running, and this reference to the reference hub gets put onto our stack here. And keep in mind, this reference to the 1344 item was consumed when we called the getOwner method, because when you call methods, you consume what's on the stack. So now we have a reference to target hub, and I'll just rename this to owner hub. And then we need to go back to here. Now we've done this call. And then there's another call here, this op inequality here. I'm not going to show going into the stack trace now because this is just to get across what's happening. What's the IL doing? All right. So here, this op inequality here, this green symbol here, what this is Northwood defined their own method for comparing two reference hubs, which is just this method. So the C# compiler names it this op inequality, and then whenever you use this operator between two reference hubs, it just says, all right, call op inequality, which then does what's in here, which tells you if two reference hubs are the same or not. So this method has two parameters, so now it consumes two things on the stack. Both of these references. So these two references, they check if they're equal. We'll assume this is normal. We'll say that they are the same, which should happen. If you kill somebody who's wearing goggles, they drop everything, then the owner of the item is the same as the person who just dropped all their items. So these references are the same, so then op inequality just returns false. And booleans are value types, so this isn't a reference to false, this is just false. The value false is on the stack. So now we're back onto here, and then this instruction here, this represents break false, and then the S is for short form. I don't really know what the deal with short form is. I think it's for small methods, like when you're doing jumps from like here to here versus like an 1,000 line long method where you have a break that skips 1,000 lines of code, So break false short form. This break, what it indicates is it's gonna likely go to another line of code. Well, not likely, but it can go to another line of code. The false represents that it should only break if this value that's on the stack is false. And then short form just represents short gap. So because we have false on the stack, when this gets called, it breaks to this IL label here, which is here. So it skips over this return instruction, and then it starts executing code here. So if this was true, if the two reference hubs were in fact not equal, this break if false wouldn't break, and then this method would return. Hopefully that makes sense. So now that we've done this break false, we consume this false value that was on the stack, and then we go back to here, and then I guess now what happens next on the stack is create a reference to SCP-1344 enum, and then we load the constant. Oh, okay, I'll have to describe that opcode. This opcode here represents for load constant. I4 is like for 4 bytes or something, or integer with 4 bytes, and then 1. So load constant integer, meaning no decimal points, 4 bytes, the value is 1. So this is like saying int x equals 1, or just calling a method with the value 1. Here, if I just pull this out, what you can see is it's loading the value of 1, which is also the same as the Boolean true onto the stack. So false would be load constant I4 0. And this represents this true value here. There's no load Boolean in intermediate language. So now we load integer value for 1, same as true. Now this is a value, it's not a reference. And then we call this method here the server drop item, which it's an instance method, and what the stack does is it consumes the lowest thing on the stack for the lowest for the first property. So consumes both of these. What it would do is it would return a pickup, an item pickup base, so something on the floor in SL. And then what it does here is it pops that off the stack. So here, I'll just draw this out. So these get consumed. Reference to newly spawned pickup. This is after the call, and then after the pop, it just gets rid of these. The stack is empty. And then it loads another reference to the item. It gets the status of 1344. And that's a property. Get property, or the getter for said property. And it returns an SCP-1344 status. That status is a value type. It's an enum. So, don't really feel like drawing it, but just load some status. And then this here, this is store local at index 0. So this is for storing local variables, which are in methods, not in a class or anything. It's like in a method into x equals 0. That's a local variable. The index 0 doesn't really mean anything here. To figure out what that means, you have to scroll to the top of your method, and then in here, these are where the local variables are for your method. So this here tells me it's a SCP-1344 status at index 0 on the stack. And then what this does here is it stores the value, it loads the value, it loads the okay, remember, just try to read it with me. Load constant, integer, 4 bytes, value is 0, which is the same as false. I mean, you can also just hover over it and then see it pushes the integer value of 0 onto the stack as a int 32. Load log 0, loads the local variable at index 0 onto the stack. Calls the method indicated by the past method descriptor. I would like to point out, shouldn't this be a call vert? Beats me. It's probably because it's a property and it being weird. This is break if equal in short form. So however, this transfers control to a target instruction, short form, if two values are equal. So this transfers control to a target instruction, just break to a new instruction if two values are equal. These can be references or values. Now keep in mind, like I said, there are references and there are value types. So like comparing 1 versus 0, so like comparing two values. You can compare two references to like identical things, like say you have a person class, and they have the same name, year, and age, and those are the only things in your class, and they're all equal. If you were to call break equal between those two different instances, those are two different references. So I think break equal would actually return false. It wouldn't break. But if you use structs, because structs are value types, if they had the same internal values, then they would break if they were equal. So when you say something like my struct x equals new, and then have some properties, you can have something that becomes identical to that struct. And it's very important to know that when you do certain things. Alright, here's another load lock 0, which is load local at index 0. Here this loads the value 8, so load constant, integer, 4 bytes, or 32-bit, then value 8. That's what it says here. And this is actually just comparing the status. It's probably like, here, I'll full screen. Yeah, the status for inspecting is 8. So it loads the constant 8, compares that versus the value of the status. This is inside the switch statement. And then you have all these break if equals, which just return. These are the same as the breaks here. Compiler's just shortening things at times. And the compiler giveth and the compiler taketh. It can make things simple and it can make things complicated. And then here, if it's never broke or anything, if it's never gone to the return, then it just runs the default here, which calls this method here. So that should be a somewhat decent telling of what the stack is, how it works. I probably drew this in reverse. It's probably 0 at the bottom, 10,000 at the top, I don't know. You can go watch a computer science video if you're interested in this kind of stuff. But just keep in mind that when you're doing IL stuff, this is what's happening, is you have this stack here and you're using these instructions to modify what's on it. So now I'll just go here, unpin this, and we can go to writing a transpiler. What I want to do here is I want to have some code here, which writer lets me just write in a file just to, change it to, look a certain way. What I want this to do basically is like, if this owner, actually, it's a property here. If owner inventory dot, then I want to get I'm gonna have to look at the type. Sorry, it's just gonna take me a while to find what I want. Okay, this should. Yeah, this dot user inventory. So then in here, if owner inventory dot user inventory, and then this contains the item and ammo. Items dot contains key. Just there, item serial. We'll change this to a not and return. So this is what I want this to change to, because after this, it actually checks the inventory to see if the item is there before, running this drop code and effects and stuff. So if I could just have the code be like this, then I'd be fine. I would have no bugs and everything would be fine. So this is what I'm going to try to do. Now, if you need help on how to see the inside of like IL and stuff, what you can always do is just make a method. I mean, I could just write this like a prefix. I could just say, you know, my test method, go to here, could just straight up, thanks for inspiration. And I could change everything, like just replace this, that, and change target hub to hub, and then in here, just have item. This error, by the way, is just bogus. I don't know what the deal is with here, but it's in Exiled for some reason, and it's annoying. So I could just write this. This would compile for me, and I can just do that. As you can see here, everything compiled properly. And then I can pull up my IL viewer here, and then I can see everything. Like, you know, how to actually do this contains key thing here. Like how I have to load everything, whether or not it's a call or a callvert. Yeah, I should explain this here. So for me, everything was normal. Whenever you use an instance method or property method, etc., you should use a callvert, which is like a call, but a callvert says, hey, run the method in this class. So when I do a callvert here, hub is at the bottom of the stack, so it's saying on the hub, reference hub, actually, okay, it doesn't run at the bottom of the stack. There is only one parameter in this method. In fact, there's none because it's a callvert. So this callvert, it's going to say, all right, there are 0 parameters, so I'm going to go back 0. Like if there was a parameter, it would go back 1 because this would be the parameter. And then it would say, all right, this is my instance. But it's not like that. So it goes to 0, and it goes back to 1. It says, all right, this is my instance for my callvert. On this item base, I'm going to call the getOwner method using what was on the stack here. Hopefully that explains callverts. So now you can see everything here. This is break if the value is true, short form. So there's nothing really unique here. Yeah, there's no unique opcodes. You can always ask for help on what opcodes do. You can read what they do, etc. For me, though, I don't really need this, I think. So, remove that. I've already got... I still need to set up my index. We're finally getting to patching. I need an offset off my index because I actually need to go to the instruction after return. So I just need to go up one, and then Exiled has a formatting thing where they just use this. They define an offset in for that. So I'm just going to use that. Now in here I can finally write some code. So the first thing I'm going to do is I'm going to go here to think about what I need. I'm going to load this, then get this, and then I'm going to load this onto the stack and then call this method. And then I'm just going to break based off of that. So first things first, I need a load arg0. So this array here already knows it's a code instruction, so I don't actually need to tell it's a code instruction here. And this is how you can create opcodes. You just provide an opcode or an operand. All opcodes are in opcodes here. Then there are many variants of load arg with just like constant values. This load arg s I could specify any amount. So like this is the same as this, but this is probably optimized. Also, this should be understandable now, because you know what a ret is. Here's an instruction we're checking, etc. So I load the arg. Next, I need to load something that's in it, so I use a call vert. And then I need to get the actual method info or property getter or whatever I want to call. And to get that, I'm going to add a using statement up here. It's going to be static. It's going to be to harmonylib.accessTools, which has some nice methods like just property getter. By the way, there's many ways to patch. This is just how Exiled does it. There's stuff called like code matchers. There's like an actual extension. There's extension methods in access tools that you can just run on types. But now I'm going to say that, alright, I'm looking for a property getter inside of this type with a certain name. Yeah, here. So I'm saying, hey, I'm going to call this property getter this type with this name. And then now in the owner inventory, I'm probably going to need just another call vert, so I might as well just change this. Change this to an inventory. This is actually a field. You can tell these things here, these are fields. This is a property getter, or this is a property with a get method. This is a property with a get method and a set method. This is a constant. These are methods. These are static methods, I think. So, yeah. So because of this is now a load field. Now from this, I need to load, I think, another field. This is a inventory info. I can load this dictionary up here. Now I'm going to load this again. By the way, this is a property of an item base, so I could change this to item base here and here. I just like to leave it as this, that way you can see everything. Then here, this is item serial. So now we load instance again, load this. And now what we're going to do is we're going to do a call. And this is just a method. This is how you do static methods. Oh, by the way, yeah, I should have been changing these more. So this is a field. So that I use field. And it looks for a field instead of a property getter. And this is a field. So I look for that. This is still a property with a get method, so I use a property getter here. This is going to be a static method that I'm going to use here. Maybe it's not. Either way, it's a type of a dictionary between a uShort and whatever is this item base. Yeah. It's got that type. And it's going to be a name of short item base. And then this is going to be contains key. You can look here. This is an actual instance method, so this should be a call vert. I don't think I actually recompiled, so I can actually... Nope, it does look like have I? Nah, I haven't recompiled yet, so my test method still exists. I can check here and see that, yeah, contains key is a call vert. And just to double check for my sanity, yep, we load the items, then the serial, and then we can call contains key. This error, once again, is just Rider being silly. One key thing to note, by the way, is sometimes when you're using these methods and stuff, you have to define stuff like the parameters. There can be an ambiguous match error, which can be quite annoying. It's basically when you've got two methods with the same name, but they take different parameters. How you fix that is, say for this contains key method, it takes a T key, which would be I shouldn't use it on a generic. Let me just look elsewhere. I know the events have tons of stuff like this. Yeah, there are many events. Most of them are transpilers. I'm sure I can probably, yeah, here. So here, this is for some event. We're loading a reference hub here. We want it to actually be a player, an Exiled player. So what they do is they do a static call to this get method. This get method, which has many overloads, is static. You can tell by that symbol there. So it's not a call vert, it's a call to a method type of Exiled's player. We call player.get. But if we were to just do this, how would it know which one of these it is? So we have to specify, get the one where the parameter is a reference hub. And then it gets this, and then it calls onto that. Another key thing to note about Harmony and patching in general is Harmony does check a lot of things for you. So you could get a lot of errors during patching because Harmony's just seeing them. It's like saying, hey, you're trying to call a method on an item, but there's a pickup on the stack. That doesn't work. I'm going to throw an error. And it just does that. Now getting back to here, we can start to finish things up. We now have a value which indicates whether or not the item is still in the player's inventory. If it is, we want to run stuff normally. If it isn't, we want to skip. So what I'm actually going to do is I'm going to use break if false. And you might be thinking, like, why do that? The previous method here, it used a break true to skip over this. Well, there's also like another thing Harmony does, which is it puts all the returns at the end of the method and just makes you break to there. I guess what I'm going to do here is show you how to use the break method to get there. So I'm going to just get an IL generator here. If you remember, this is a parameter I can get. And I need this, so I can do label, return label equals, and then generator dot define label. So this just makes a label, just like in here, when you're doing jumps and stuff. You know, it says it's jumping to here. Multiple instructions, or instructions can have multiple labels, so that's fine. What I'm going to do here is new instructions of new instructions.count -1 .labels.add, or just with labels return label. I think your motto got mad at me for this, so fine. Do labels.add. You can do this like this, but I don't, because that looks weird. This is more intuitive to me. So we're just adding this label to the last instruction in the list. And if you remember, lists are 0 indexed, so the last item in a list would be at the amount of items it has -1. And now here I just provide the return label, and this is where the break will jump to. So if it doesn't contain the key, it just goes to the last instruction, which is return. Otherwise, it just runs the method like normal, because we're inserting these instructions into the middle of already existing instructions. We're literally just inserting this, but instead of return, it's more like if I were to define this and then just go to exit. And as a go-to statement, you can literally just say, alright, go to this place. This is basically what's happening, but Harmony is also going to add this. So it's just going to look like this at the end. If you want to see what your transpiler has created, by the way, there's an important attribute you can add called Harmony Debug. And if you run your transpiler when it has this, your computer or whatever, it will log the actual intermediate language instructions, IL instructions, to a .text file, or it'll print whatever error you've gotten. So that can be very useful. I don't know how it'd work on a server, but on Windows it just prints to desktop, so who knows. Now that we have all of this, this should work. I don't actually need this debug. I'm going to add my references. I'm going to remove redundant stuff. I'm going to just build this. If you remember at the start of this video, under handlers internal round, I reset this changing role thing here. So this would typically cause this duplication bug with the goggles. But I've just changed things now, and I've built it. So I go to where Exiled is stored and built. I get events, because this is the only thing I've changed. And the code I'm using is as up to date as possible. I can just copy it here, restart SL, start it, and then I'll show you what happens. Oh, we got a patching error actually. Didn't expect that, but I'm a bit dumb. Apparently, this index actually, the lowest should go to 0. Interesting. Oh. Man, I'm freaking... I hate writers sometimes. Do keep in mind, when you autocomplete this stuff, you gotta check this, alright? Writer is very mean sometimes, and very stupid. Still better than Visual Studios in some regards, though, like the IL viewer. And now my patch runs. So yeah, you can find a great deal of errors. If you've got any errors or problems patching, just go to the Exiled Discord. It is so much easier to just ask someone more experienced than you for help. Now that we're here, just gonna wait to connect to the centrals. Okay, finally. Okay, I'm just gonna try to join my server. Just gonna start around, make myself a tutorial, spawn a dummy, make him a D-boy, bring him here, clear his inventory, give him goggles, give myself a weapon. Now, typically, this item would be duplicated, but if I kill him, it's still freaking duplicated! Oh my gosh. These are duplicate serials, as you can see. So there's the bug, and this somehow doesn't fix it. Oh, let me double check my logic real quick. This literally removes from the items. How does this get called twice? SL is synchronous, so when something happens, SL runs like step by step. So what should happen is player dies, the role gets changed during death. It calls the exiled event here, which, you know, calls server drop everything. And then it goes to here. It sees that the user's inventory still contains these. So it doesn't do this. It drops the item. And then it returns. And then we go back up the stack to when the player dies. That method keeps executing. It then tries to drop every item. We go here. and then it goes to here and it says, hey, the serial isn't contained. Go to exit. And then in server remove item, which is in server drop item, I don't see any returns here. That should happen in a weird way. Let me check this. I mean, this literally checks for the item. The problem here, though, is that the server remove item runs after the pickup. So this remove item is basically a try remove item. Tries to get the item, calls on removed. If it was the current item, gets rid of it, and then it just destroys the item. Which should even call on destroy. That makes this bug even weirder. Great. I have to think more about this. Oh, it was the average patching experience. You think you're gonna fix something and it doesn't. So on destroyed should be called even like earlier, which should unsubscribe to this method, which should stop this duplication. And yet I bet if I were to print out what the stack trace of what happened, there'd probably be one item created from on changing role, and then one item created from server kill player. I guess I should check server kill player. I mean, this should literally just drop all the items before even calling this event. So, man, I freaking hate how this all is coded. This shouldn't even work. I'm starting to doubt if the DLLs I'm referencing are even up to date. I'm going to assume that this is like for other things. Like maybe a certain SCP kills you and you lose your items. So call server drop everything. Oh, and then it sets the role. Alright. So server drop everything. Everything gets dropped. I think that was backwards in my stack traces. So I'm going to look for that. I literally printed the stack trace and I swear it was reversed. No, this is normal. Yep. So it calls this once. It should go through every item and then drop that item.
Mobile Task Force Unit Epsilon 11, designated NEMA 12, has entered the facility. All remaining personnel are advised to proceed with standard
And then in the inventory item would call this event.
Exercise caution.
Oh, let me double check my patch works, logically speaking. So we go to here. After the first return. Oh my. Yeah, our patch is skipped because of labels. I forgot to mention that. Yeah. Whenever you're inserting stuff, okay, you just somehow need to sometimes mess with labels. So I actually need to use this bigger constructor here so I can move labels from. Let me just figure out if the indexes work. What I'm trying to do here is when we insert this, remember this is really built like this when we pass it off to Harmony, and Harmony's going to change this. The skip that's here, that would skip this return, if they were equal, it goes to here typically, and we never told it to go to here. That's the problem. So in the IL, just need to check my indices. So I'm targeting this instruction, I'm inserting into here, and I need to move all the labels from this instruction to mine, which I am doing now with this. So, this is not blocks, labels. Well, it's still the average patching experience. You think you fixed something, and you forgot something. Still no patching errors. Hopefully this time it'll work. I would definitely say the hardest bit of patching stuff is trying not to forget all the different ways things can go wrong. So now if I kill them somehow, boom, no more duplication. Our code ran, it said, hey, the item's not in the player's inventory. Don't drop it again. And then it didn't drop it again. Now we're chilling. So there, my patch works. Here, you can see all of it. I tried to share my process. I even drew out what kind of happens. And now I have all of these changes in GitHub Desktop. Now I can commit these two to my branch on my own fork, and then I can create a pull request to the Exiled repo so other people can look at my changes, be like, yep, looks right, and they can merge it. And then instead of having this fix here, which used to, if you remember, look like this, which wasn't really that good because it wasn't old behavior, now it's the old behavior. Anyways, thanks for watching. I hope you learned. I'm sorry this was boring, but hopefully you understand now.